Hi, everyone. Thank you for joining our Kubernetes Masterclass this Tuesday, August 11th. We'll be talking about Helm Charts and security with JFrog. I'm Connie Lin. I'm the manager of global events here at Rancher Labs. And today we are joined by Deep Data from JFrog, Community Product Manager. Deep, you want to say hello?
Hello, everyone. I'm pretty excited to be here.
Great. Thanks for being here today. We're looking forward to the session.
Okay, so thank you, everyone. Thank you, Connie, for having me come talk about reproducible security with Helm Charts. I'm really excited to be here. So I'm going to just kick off by talking a little bit about myself. I am the community product manager at JFrog. I get to work on all the really fun, free community, open source and open source adjacent projects. My name's pronounced Deep Data, just like you see it. And I'm always really interested in talking directly to developers. So, as the community product manager, really my job is just to hang out with you, learn from you, and get your input on some of the stuff that we're working on. So feel free to email me. It's deepd@jfrog.com, or you can ping me on Twitter. I respond pretty quickly. And these slides will be available after the webinar, so you'll have my contact information. All right. Cool. So here's today's agenda. So we're gonna kind of go through, Helm 3 and Helm Charts in sort of 5 different sections. I'm going to spend about 10 minutes talking about some of the new changes that have come with Helm 3. I'll then do some brief overview of what creating a Helm chart looks like. Then we'll really dive into the security aspect, which is the main part of this talk. Then I will do kind of a small demo. I will show you what it means to package and sign a chart, and then to verify that the chart has been signed, and what it means to have a provenance file. I will then talk a little bit about using a trusted source for your Helm charts, and then I'll show you how to deploy a chart to Rancher's UI, and some of the other sort of enhancements and considerations that you can do with your Kubernetes applications in Rancher. Cool. All right. So we're going to begin the discussion by talking a little bit about Helm 3 and how we got to where we are today. So many of you might have heard that Helm has recently moved from an incubation project to a fully graduated project within the Cloud Native Computing Foundation. This means Helm and the Helm community has reached a certain level of maturity. And with the extensive use of Helm, I'm reading that it's used by more than 70% of Kubernetes deployments are now using Helm. That means security becomes a concern now that these are being used in production. So let's look at some of the changes in Helm 3 and understand how we get to this conversation around securing your Helm charts. Okay, so briefly, you may know that Helm is a package manager for Kubernetes. Helm was introduced at KubeCon in 2015, so it's less than 6 years old. And a year after its initial release, Helm 2 was published in mid to late 2016, and it was merged actually as a sub-project of Kubernetes. And because of the way Helm developed, originally it was independent of the Kubernetes project. There were some server-side components that got sort of brought into Helm 2 that I like to think of as legacy components, which we'll talk about. So when Helm 2 became a full-fledged CNCF project in 2018, the community was already underway working on Helm 3, and one of the biggest things that they wanted to fix was the server-side component and removing Tiller. So we'll talk a little bit more about Tiller and how it relates to security. But the great thing about Helm is basically it assists with installing your Kubernetes applications through collection of manifest files. And as a package manager, Helm can then help you upgrade or roll back your installation. It can help you monitor your deployments. There's a lot of great commands that will really help you understand the state of your application. And then, of course, in November of 2019, Helm 3 was officially released. Okay, so the biggest single improvement to Helm 3 was the removal of tiller. Like I said, tiller was basically a legacy concept that had been created before Kubernetes had strong support for role-based access controls, and tiller caused some security issues because of how permissions were handled with root access. With Helm 3, the new architecture interacts directly with the Kubernetes API. Access credentials are managed directly by Kubernetes API and the RBAC system. A few other improvements that came with Helm 3 is dependencies. So I'll show you this a little bit later in the webinar, but dependencies, they used to live in your requirements.yaml file, but as the Helm community works on standardization, now your dependencies are actually part of the chart.yaml file. Another cool update is releases and namespaces. Release information is in Helm 3 is now stored in the same namespace with the secret as the storage mechanism for the release information. Helm 3 also has three-way strategic merges. So in Helm 2, there was a two-way strategic merge process. Helm 3 actually takes the live state of the application resources into account, in addition to the manifests in old and new Helm charts. And it actually helps preserve any manual or automatic changes that might have been applied to those resources. Helm 3 is also bringing in OCI as an experimental feature. So the Helm community is really excited about exploring the use of OCI registries for storing and distributing charts. This is actually going to continue to move Helm towards a more a secure ecosystem. Helm 3 also brings in a new way to do chart validation. There's a JSON schema which is supported and helps define the structure for the values in the chart. You can use the Helm CLI to validate against this schema. Helm 3 also has improved CRD support, and there are also a new type of chart, which is called a library chart. And these were introduced basically to facilitate sharing of like short snippets of code between charts. Library charts, they're not meant to install anything. They're really just used in your dependencies to provide data around other charts. Last, there are a few commands that have been added in Helm 3. So, Helm as a package manager has a really important job to do in controlling the life cycle of your Kubernetes applications. When you deploy or upgrade or roll back, Helm manages this for you. And these three new commands really help you see sort of the state of the deployment. So Helm status, Helm list, Helm history. And along with these commands comes actually a lot of new support for tooling. And some of those tools we'll actually get into today. Okay, so let's talk a little bit about the structure of a Helm chart, and what I'm showing you in this presentation is basically the structure of a Helm 3 chart. So I'll dive into each sort of part of this in a minute, but what's really cool about Helm is it has immutable configurations, right? So because Helm is there as your package manager, when you deploy your Helm chart, when you keep those manifest files, basically the same, they're immutable. This gives you true configuration as code, and this immutability makes sure that you're managing all your application states in one place. So in the context of security, this control is really essential. When you publish a Helm chart, you can take care of all the security issues beforehand, at least most of them. And this is really where the immutability part of what Helm does really shines. The other thing about Helm as your package manager for Kubernetes is the metadata. So again, control is really important to security. So is transparency and the ability to track each piece of your deployment and essentially what's happening with all the metadata. So the metadata provides transparency, which is really important to make sure that your application, isn't being tampered with or hasn't broken in some way. And one of the products that I manage as a product manager at JFrog is a new Helm central repository called ChartCenter. I'll show you a bit of ChartCenter sort of later on in the demo. But ChartCenter, one reason it was built was to really provide you true transparency into all of this metadata that's happening around your Helm charts. And we give you a really recursive view of all the issues and all the versions of that chart over time. Okay, so I'm now going to sort of start talking about more of the security side of Helm, and to kind of put our minds in the right context of how this works, we're going to sort of pretend like we're creating our first chart. And by doing this, I can kind of show you what to look out for and what to keep in mind as you continue to work with Helm charts and hopefully soon start building your own. Of course, creating a Helm chart's very simple. So, as long as you have Helm installed, it's one command, Helm create, and then the name of the chart. You will get a bunch of default files like this. And the four main things I want to point out to you are the two most important files when you first create this chart is your chart.yaml file, and then your values.yaml file. And then there are two folders to pay attention to. So there is your templates folder, which is a huge majority of what actually is scanned by the Kubernetes API for your deployment. And then there is also a charts folder where you can host subcharts. And we'll talk more about subcharts in a bit. So just to give you sort of a quick view, the chart.yaml file is where the metadata that describes the chart lives. So here you can declare things like the name of the chart, the version, you can provide a description. You can also indicate whether this is your, an application chart or a library chart. And as I mentioned before, one thing you're going to see here is the dependencies declaration has now been moved into the chart.yaml file. So if you look at a Helm 2 chart, these dependencies, this declaration is in its own file called requirements. Now in Helm 3, it's actually in the chart.yaml file. So pay attention to this when you're working between your Helm 2 and Helm 3 charts. The values.yaml file is the place where basically your default configuration options live. And working with Kubernetes, you know that this can be overridden during the installation with any user supplied values, or if the chart is actually a dependency of another chart, these default values can also be overridden by a parent chart. And the values.yaml file is really where you can set a lot of your configurations options. You can provide the replica count, service count information, security context. This is kind of the main place that you're changing those key value pairs in your Helm configurations. Okay, so the next thing to talk about is the templates folder. So when you first start using Helm, you'll hear a lot about templates, and these are managed in the templates directory. And this is where Helm finds the YAML definitions for your services and your deployments and your actual Kubernetes objects. So if you already have sort of a working Kubernetes application, a working Helm chart, and you're creating your own Helm chart, you can basically copy those into the templates folder. And in the templates folder, you have these two sort of important files. The service.yaml file is just the default file for services that can be declared. You can actually declare your services using anything with like a service file name, and you'll see that a lot of Helm charts don't just use service.yaml. And then the other file that we have in here is your deployment.yaml, which generates a lot of the metadata around the deployment. So as I mentioned, here you can define the set of services for your pods, and with deployment.yaml, you'll generate that information that'll help you track the state of the application later. All right, and the last thing just to mention as you're looking at your new Helm chart is the charts folder. This directory is where we're going to place all the dependencies that we declared in our chart.yaml file. Okay, great. So now we're going to talk about Helm chart security. I wanted to sort of get the basics out of the way. So if you're new to Helm or you're not super familiar with sort of how the structure of the Helm chart is, now you have some rough idea as we talk about the security side. Okay, so know the reason we're all here is to learn more about security aspects of Helm. So I'm going to cover sort of a lot of different pieces of Helm. What I really want you to know as I go through this presentation is that you're going to walk away with a high-level understanding of each piece that goes into securing your Kubernetes application and where Helm plays a part. Kubernetes and Helm are, of course, interrelated. So a lot of the concepts that I'm going to cover aren't specific to Helm. In fact, many of them are actually from the Kubernetes community. And now the Helm community is basically building tools to overlay the kind of controls that we have in Helm charts with things that you're already doing in Kubernetes, things like your role-based access controls, your security policies, etc. So hopefully as I go through this, you'll see how each piece actually applies to your Helm charts. You'll get a great overview of security and you'll be able to build kind of your own blueprint moving forward. One thing that I will show you is once we sort of finish going through the security side, I will show you kind of how to deploy a application. I want to show you how managed services such as Rancher can help you, do a lot of the security steps that I'm talking about. And as we go along, I'll point out where, a security step might be specific to Helm or where it's a tooling that can be used in a managed service. Maybe like a cloud provider, Google, Amazon, they also provide some tools that can help you with the security side of Helm. All right, so the first thing we're going to start with is I'm going to talk a bit about resource quotas and checksums. These are just very basic things before we dive into more of the specific stuff. So one thing when you're deploying your Kubernetes application and working with Helm charts is don't forget to set your resource quotas. This is going to basically make sure that if there is unauthorized access to one of your applications, that it doesn't take over all the memory and all the space on your machine. This is just a very important step to keep in mind when you're deploying, your application. And here I'm showing you a screenshot of sort of what this looks like. This is an example from a Helm chart called Git. And you can see that, Git has basically set a memory, a CPU. It's also set actual limits, so it's not going to go over 2 GI. And it also shows how many sort of CPUs are being used for this chart. Next, I want to briefly cover SHA-256 and SHA-512 hashes. So when I talk about Helm chart provenance files and signing and verifying your chart, the output that you're going to get from that Helm verification is these SHA values. So, if you're not familiar with SHA, it's a secure hashing algorithm. SHA-256 is basically now being used as like the default for all checksums. And a checksum is just a way to verify that a piece of digital data hasn't been changed. This helps to make sure that it didn't, break or something happened to it in transit. It also makes sure that somebody didn't try to change something in the file. When you put something into a hashing algorithm, it spits out this character string that you're looking at here. And if you make any changes to the underlying file, the output completely changes. This means if someone were to go into your Helm chart and try to, inject any malicious code and change it and then pass it off as the same chart, there would be a checksum mismatch, and you could know very quickly that something changed in that chart. So later when I show you Helm verifications, you're going to see how this works. But like I said, it's a digital handshake between the chart author and the consumer to verify the integrity of the data. Okay, so now the next part of our Helm chart security blueprint is going to be signatures. So to start, if you already know, sort of how a signature works, you're going to first make sure to have a public and private key probably set up on your machine. I like to use GNU-PG, and there's also a plugin called Helm GPG, which actually helps make the signature even more secure by providing a passphrase. So you can install GPG using a link like this, and then you generate your key, and with the Helm GPG plugin, you'll enter a passphrase. This is going to help make sure that your signatures are even more secure. And this is just an example of your public key. You can see my fingerprint right there. And then one thing to know when you're actually signing your chart, and later when I go to the demo, I will walk you through exactly how to do this in each step. But one thing to keep in mind when signing a chart is if you're using GPG 2.1 and above, you do have to transfer the keyring into the old file format. So you can use this command here, the GPG export secret keys. This will move it back into the old file format. And then you can actually use the command below, the Helm package sign, provide a key name, and then point to your key ring. This is going to provide your digital signature on that package chart. So you'll get an output that looks like this. You'll have your chart TGZ file, and then you'll have your TGZ provenance file. So basically, what happens is when you create the provenance file, this is where your fingerprint is stored, right? So this helps anybody that's using your chart later down the line understand that it's been verified by the original author. And this is great because as you get deeper into the Helm community, you'll realize a lot of people are, installing Helm charts, they're copying them, they're changing the configurations, and sometimes they're actually pushing them back to chart registries with the exact same Helm chart name. And it can be difficult to understand who the original author was. This is just one more way to verify that the chart that you're installing, that the intent is that this came from the original author. So when you do a Helm verification, you will get the SHA value. And like I mentioned, this is basically verifying that there isn't a data integrity issue, that the file hasn't changed. If it has changed, when you do Helm verify, you'll get a checksum mismatch error. Okay, so the next thing to talk about is pod security policies and RBAC. So, knowing sort of the community I'm speaking to, I'm sure this is stuff that you're pretty familiar with from Kubernetes. So I'll just cover it sort of briefly. So as you know, when you deploy a Kubernetes application, you can create these security policies for your pods. These do everything from manage the state of your state of privileges in your containers. You can create namespaces and assign the pod security policies to those namespaces. And we're also going to talk a little bit about network policy and how you can control traffic that comes in and out of each pod. And this is actually very, very important to securing the pods. It provides an additional layer of hardening. So when you set your pod security policy, some of the things that you should keep in mind is it's really important to disable privileged containers. This means, so this is basically when you give a user, some access to privileges, you want to disable the privileged containers. You don't want them to sort of get privileges that weren't intended. And so you can set this flag here in your pod, privileged false. Another really good best practice is read-only file systems. So you don't want, write access for your application when it's being used. So it's good to set this as read-only. I understand that sometimes read-only systems are not practical in all situations, but you should use it by default if you don't have a good reason to have write access for users on your application. Also, prevent privilege escalation. So again, you don't want users gaining privileges that they escalating any privileges that weren't intended. And the last one is to prevent containers from running as root. So this is something to set up when you're building your Helm chart. Again, fortunately, it's very easy to do this. You can just, in the key value pair, must run as non-root, set that to true, and this will make sure that your pods are secure. The last thing to do is make sure to group your policies together. So this is just a quick example. Put all your policies in one file. That will be easier to manage that way. And this is a theme you're going to see as I talk about Helm security overall. When you're dealing with secrets, when you're dealing with network policies, it's good to have everything in its place in one place. And it just makes accessing and changing the state of your security much better. And of course, the more organized you are, the safer your application will be. Okay, so let's talk a little bit more about pod access. Clusters and pods, they're highly configurable. So for example, namespaces and service accounts can actually be used to define and divide a cluster's resources to multiple users. And you can actually grant unique permissions with each group. And then as I talk more about network policies, you'll see that that is also highly configurable to how the ingress and egress traffic flows and how users are able to access the traffic and the traffic between the pods and the network. So again, with Kubernetes, you have role-based access control. The main things to keep in mind is you'll have a role assignment or a cluster role assignment. Then you need to bind that role or bind the cluster role. And then you can use these service counts, which are basically used as groups to assign privileges to like a specific user or a group of users. So sort of in this drawing, you can kind of see how that works. You'll have various namespaces. You may have a user named Ruby, and as you provide the right access credentials and certificates, and you assign them a role binding, you can basically assign them to a specific namespace. So one thing to know is that a role applies to one namespace or a specific namespace, and cluster roles can apply to all the namespaces at once. And there's a number of actions that you can assign to each user. Some of those are listed here: get, list, update, delete, etc. Service accounts, again, are the accounts that define services, but they're also used to, they're the accounts that creates the sort of group of privileges that you would assign the users to. And you can actually define multiple service accounts in one place. Again, then you assign your human IDs to these service accounts, and this helps you manage, how your users are interacting with the objects in your Kubernetes API. Okay, network policies. So here you're going to see an example from the Gatia chart of your service accounts being defined. Here at the bottom, you will also see the Gatia chart doesn't have a network policy enabled, but a network policy is actually important because it specifies how your pods are allowed to communicate with each other and also how they communicate with other network endpoints. These policies can be used to limit your traffic, ingress and egress traffic according to the pod IP address and ports and protocols. And in the Kubernetes space, each pod is assigned a specific IP address, and this is going to help you manage sort of the network policy for each specific pod. And you can see here that using labels, that is how one pod can be assigned sort of certain permissions versus another pod. Ingress is incoming traffic to your pod, egress is outgoing traffic, and you'll use these to signify, how the network is interacting and how the pods are interacting with each other. All right, so the next thing to talk about is secrets management in Kubernetes, which is a pretty hot topic. So this sounds really obvious, but don't store your sensitive information in plain text. Secrets are very similar in Kubernetes and Helm to config maps. They're just key value pairs. The information that you want to keep encrypted, to keep secret, you should actually remove it from your main YAML files and store it in its own YAML. You can call it secrets.yaml. And secrets obviously are sensitive data. There's a few things that you want to keep in mind with secrets. There's a few best practices. So one, it's always important to have logging and monitoring tools set up. This is just going to help you have transparency into what's happening with your application, but also provides transparency into what's happening with secrets. So API credentials, username and passwords, database credentials, all of it can be monitored. The next part, which I'm going to show you a little bit more about, is encoding and encrypting secrets. So, if you're familiar with Helm, you're going to know you can encode your secrets in base 64, so they're not just showing up as plain text. But you also need to encrypt the secrets. Base 64 encoding is not encryption. Pretty easy to decode that. And you don't want secrets sort of living in your files in plain text. You have no idea where these Helm charts are going to end up later down the line, and you don't want to not follow this best practice and forget that you've got your database credentials just totally exposed in your files. Another important thing is it's important to rotate your credentials. I'm not going to show you too much of that today, but I will mention some tools that can help you sort of do more advanced secret management, and rotating credentials is an important piece. And 4 is making sure to isolate where your secrets live. So again, remove them from all the different YAML files that they might live in, put your secrets in one place, and keep them encrypted there. So the tool I want to show you is the Helm Secrets plugin. It's a basic plugin that's being used widely in the community now. Again, it just encrypts your database credentials, API tokens, usernames, and passwords. So I'm going to kind of give you a step-by-step view using these slides. So first, you want to make sure that you have a public and private key. So you can generate that key any way you want. I use GPG. So step 1, make sure you have your public-private key. Step 2, install the Helm Secrets plugin. And the other piece about the Helm Secrets plugin is you want to make sure that you have SOPs installed. So brew install SOPs if you're on a Mac. This is going to basically help you store these secrets in Git and manage the encryption and decryption later down the line. So this is an important step for the Helm plugin. Install SOPs, put a sops.yaml inside a folder called helm_vars, and it's a prerequisite step to encrypting secrets with the Helm Secrets plugin. Once you have your plugin installed and your SOP set up, you're going to have your secrets in your key value pairs. Put them in their own file called secrets.yaml, and then it's basically as easy as saying, Helm secrets enc for encode, point to your secrets.yaml file. You'll see it in the terminal. It'll say that it's encrypting your secrets, and then a minute later that your secrets have been encrypted. As I mentioned before, secrets management is is sometimes complex. So depending on the complexity of your Kubernetes application, and again, how many database credentials and API tokens and usernames and passwords, and wanting to make sure you're rotating those credentials correctly. The Helm Secrets plugin is not going to be able to manage all of that, but HashiCorp Vault, which is also something that Rancher talks about, is a really great tool. It's a little bit more complex to set up, but it has much stronger secrets management capabilities than the Helm Secrets plugin. All right, really quick, one thing that's important to do when you're creating your Helm charts is just a basic lint. So you can do a dry run, you can do Helm get manifest to understand what's happening in your manifest, and then Helm lint will basically go through some basic linting for you in your Helm chart. It'll spit out this thing in terminal. It'll say 1 chart linted, 0 charts failed. Of course, if it says 1 chart failed, then it'll provide you some note about the error and what line that failure may have happened on. It's really great because you can go back into your Helm chart files and go to that line and try to understand where your syntax may have been incorrect or where the problem might be. Certificates. So we talked a lot about encrypting secrets. We talked a lot about how checksums verify your data. Certificates are basically along the same line. They make your they secure your data in transit. So a really common certificate management tool in the Helm community, which is also again used by Rancher when you install Rancher, is of course Cert Manager by JetStack. You can actually install Cert Manager from ChartCenter. So I mentioned this before, but when I show you ChartCenter, I'll show you the Cert Manager Helm chart, and it's as easy as pulling down the chart from ChartCenter, doing a Helm install with the right namespace. My namespace is Cert Manager, and then you can use you can use the kube control to check the rollout status and the deployment of Cert Manager. TLS is just something you should be doing in general when you're launching cloud applications, and Cert Manager is a really popular way to do so. Okay, now getting towards kind of the end of the talk, I want to talk a little bit about dependencies and mitigation. So I mentioned before that you have your charts directory. This is where your subcharts are. You can actually create Helm subcharts as well very easily. You're going to see that there's a lot of Helm applications that are becoming very complex, and they're using other Helm, the Kubernetes applications, and they're using other subcharts in their application. And as I talk more about security and security issues in your dependencies, I want you to understand that you can, swap out certain parts of your Helm files, and one of those things that you may need to swap out at some point is some of the subchart information. Okay, so getting to the end of the talking portion, I want to talk a little bit about ChartCenter. So we built ChartCenter because kind of the de facto solution of Helm Hub. Helm Hub is basically an index of Helm charts from around the web, and Helm Hub brings in charts in their UI. You can go to their UI and you can click on a chart and you can install it, but that installation is happening from the source. Helm Hub, again, is just an aggregation, so it's not a trusted registry. What ChartCenter does is we pull in those Helm charts from the source, we cache them locally, we scan them for security, and we provide you all the metadata around that state of the chart. Using a trusted Helm chart repository, it's going to make your life a lot easier. You're going to know that the original source of these charts hasn't changed. When you use charts that are immutable and cached, for every version, you'll know that those charts have remained intact. So using a trusted registry is actually really important to securing your Kubernetes application just from the start, knowing that it came from a trusted source. So what I want to do is I'll talk a little bit about ChartCenter here, and then I want to switch to kind of the demo view. I'm going to walk through ChartCenter security, and then I'm going to go straight into the demo. So as I mentioned, ChartCenter is the free community product I mentioned. And in the context of this conversation, what I want to talk about is dependencies and the security tab. So here in this view, you're just seeing a screenshot of the GT chart. And here on the dependencies tab, you're seeing information around a subchart. You can see it's got MariaDB as a subchart. We show you all the Docker containers. And when I show you the live version, you'll see you can actually drill down into those containers and see most of the components that live within the container. ChartCenter basically does all of this for you from the start. So, we're scanning all the dependencies. We're providing you all this metadata from the beginning. You don't actually have to do anything. We give you the chart version, the Helm version, the application version, whether the application is a library chart or a regular application chart. We'll provide you the status, active or deprecated. We'll give you the license. We'll show you the number of times the chart has been downloaded in case you care about popularity. And we provide you basically immutable versions. So every version is cached, and you'll know that what you see is what you get. So let me switch now to my live view. We'll just go main screen. Okay, cool. I will put these speaker notes down and make sure you can see ChartCenter. So here I've got the GT chart, and again, I mentioned the dependencies tab. Getting transparency into your dependencies is really important as you continue to work with Helm Charts. And what we really care about here at ChartCenter is how the security information is provided to you. So luckily, the GT chart doesn't have any security vulnerabilities. You can actually see, most versions except for version 1.3.1 is totally vulnerability free. If I click on version 1.3.1, you're going to see we've now loaded in that security information. So what we give you here is we give you the CVE, which is the Common Vulnerabilities and Exposures ID. I'll talk a little bit more about that briefly in a minute. We give you the severity level of the issue, the Docker container where it lives, the actual component, the version of this issue or the component, and then a brief description of the security issue. So if you were ever working with a Helm chart and you wanted to make sure that it was safe and secure, you can easily come find it from ChartCenter. You can glance at each version and see what versions are safe. And if there are versions that are vulnerable, I think the linkered chart. Let's see. I know the Nginx chart, for example, has many security vulnerabilities that are known about. You can actually see that every version for this specific Bitnami Nginx chart has some vulnerabilities. And understanding, again, what those vulnerabilities actually are and how they are managed in your dependency tree will be really important to your application. Okay, so what I want to do next is actually show you a bit more of a demo. For the demo, what we're going to do is I'm going to, there we go. I'm going to basically pull down a chart from ChartCenter. I'm gonna just open up the TGZ file. We're gonna inspect that chart. I'm gonna show you some of the security considerations that we just went over. I'm then gonna show you how to package and digitally sign the chart. We'll do a Helm verify. And I'll show you how the provenance file actually works. After that, I'm gonna take my packaged chart. I'm going to upload it to my private registry. So I'm using JFrog Container Registry to host my charts, but you can use any private registry that you want, GitHub, Chart Museum, etc. After that, I'm going to show you in Rancher how to pull in these custom charts that you're creating in their catalog. We'll deploy the custom chart, and then I'll show you, I'll walk you through some other things that the Rancher UI provides you in making your charts a little bit more enhanced and secure. Okay, so let's start. So for this demo, what I'm going to do is I'm going to pull down the Joomla chart. Joomla is like a Drupal or kind of like a WordPress. It's a CMS system. I'm using this chart specifically so that when we deploy it, I can show you the deployment in the UI. So to pull down the chart, the first thing I need to do is using the set me up, need to point to ChartCenter as my Helm chart repository. So if I open up my terminal here, and I've already done a lot of these steps, but we'll walk through it anyway. Make this a little bigger. So I'm first going to make sure that ChartCenter is my repo, and then I'm going to grab this specific chart. So in this command, it's a Helm installation, so you can install this chart directly. But for the purposes of my demo, I just want to pull the chart down to my desktop and open it up. So to do that, I'm going to do Helm pull and then the name of the chart. Okay, so if I come down to my desktop, what I should see is I've got the Joomla chart right here. So we're going to go ahead, we're going to open up the TGZ file, and now I have the folder. I'm going to open that up in Sublime Text. Okay. So as I mentioned before, you know, I now have my Joomla chart sitting here. What you're going to see is the Joomla chart has some of those security best practices that I mentioned. So scrolling down on the values.yaml file, they have already set up their resource quotas, the resources here. They have pod security context enabled and the default group key value pair right there. There's a default container security context enabled. So the best way to think about your building a Helm chart is, you know, where to start is taking existing Helm chart applications and understanding how the security has been applied there. And you can move that information over to any Helm charts you're creating. Again, Helm charts are just manifest files. They can be changed. You can go into the charts folder and change out dependencies. So just for this sake of this demo, what I'm going to do is I'm going to create my own custom Helm chart. We're just going to copy and paste over the Joomla files into my custom chart, so I don't have to build out a new application by hand. So let's do Helm create. We'll call it demo chart 1. And then you're going to see on my desktop, I've got a demo chart 1 created. And we're going to open that up in Sublime Text as well. And as I mentioned here, by default, you have your values.yaml, you have your chart information, templates, and then your charts folder. So if I'm building my application for the first time, you know, I have just the default values in here. So I might want to set my replicas to 3. I may want to make sure that I enable the security context and the pod security context. And then lastly, of course, is how your resources are set up. So by default, when you create your Helm chart, you do have this information sort of sitting here. You can just you know, uncomment it, and you'll have sort of the default resource quota limitations set up. You can also change them if you'd like to. But for this demo, since I don't have time to build a full chart, what I really want to show you is how to assign and package any custom charts you're creating. So I'm going to go ahead and I'm just going to grab this Joomla chart files. I'm going to put them into this demo chart that I just created. Okay, and you know what I'm mimicking here is basically creating my Kubernetes application. So let's open up that demo chart again. and refresh it. Yep. So, obviously this is the Joomla files, but we're going to pretend that we created this from scratch. So as I created my my new Joomla application, custom application, I might want to update the application version. I may want to create a custom description and say this is Deep's custom Joomla chart application. I can even do, I can update the icon if I want. I think I have an example just for fun of that as well. Let's see. Oh, where do I have that? Let me go grab my custom graphic from GitHub. Here we go. Okay, so since this is my chart, I get to have my own graphic. Sorry, I have way too much open. Hold on. Nope, forgot to save this. Custom application. I said I wanted to update the icon. Again, if I'm the maintainer of this custom chart, I want to make sure I'm providing my maintainer information. When I talk a little bit about publishing your own charts, I'll show you why this is even more important. And then just for the sake of this demo, I'm going to keep the source the same so that my Joomla application actually launches. So now I've got my demo chart one. Again, it is Joomla, so just keep that in mind. When the chart is packaged, it'll actually pull the metadata from the manifest, and you'll see it's packaged as a Joomla application. So if we open up the terminal, what I have created here is my public and private key. So you're seeing my public key right here with the fingerprint. And to sign the chart, I'm going to use this command here. It is package sign key. For my key, I'm just providing my information. And then let's keyring. And then the name of my chart here that we're packaging is demo chart one. Provide the passphrase for my key. As you can see, it says successfully packaged the chart and saved it. Again, it saved it using the metadata. So this chart is the Joomla chart. You're going to see the file right here, TGZ. And you're going to also see the provenance file has been created as I signed the chart with my key value pair, my public and private key. And then essentially, if you are using a Helm chart and you want to check the provenance, basically you want to check that the chain of custody hasn't broken from the author to you using the chart, you can do Helm verify the name of the chart, TGZ file, and you should get an output that shows that digital fingerprint. So as you can see, this chart has been signed by me, and you'll see that the fingerprint basically matches the one right here. Cool. Okay, so the next part of the demo is I just want to show you how to deploy this custom chart on Rancher. To do this, I am actually first hosting this chart in a private registry, which I mentioned, which is the JFrog container registry. So again, the JFrog container registry, it's a totally free Helm chart registry. I'm going to log into my account here, and what I would usually do is I would create my own. I would create a Helm repository to start. So if I go to administration and repositories, you're going to see I have a Helm local repository set up. I could, if I wanted to, create a totally new Helm repository, but I've already got one. And in my CLI, I actually already have the command installed to push my local custom Helm chart up to the JFrog container registry. So I'm going to do that with a curl command. In this curl command, I'm basically providing the username and password for my JFrog container registry account. And then what I need to do is signify the folder that this custom chart's going to live in. So this is my basically Joomla custom chart, and we'll just call it Joomla. And then the location that this chart is on my local machine, need to point to that. So it is Joomla 8.4. And it's successfully been pushed up to my private registry. This is the output you're seeing, checksums to verify that is now in the JFrog container registry. So coming back to JFrog UI, if I go now to my repositories and click on Helm local, sorry, this view. If I go to Helm local, you're going to see my Joomla custom Helm chart is now up in my private repository. Okay, so now that I have the custom chart in a hosted repository, we're going to add it to the Rancher catalog and make sure it's deployed. So moving over to Rancher, we're already on the catalog view. I'm going to go back to the global view. So here, you're probably pretty familiar with Rancher, but if you've never worked with catalogs or custom catalogs, you come over here to Tools and you click on Catalog. Rancher has a bunch of default catalogs that have Helm charts from stable repositories already set up. They have both a library of Helm 2 charts as well as new Helm 3 charts. So just to kind of show you how to add a custom repo, what I would do to add my own private repository here is I'd hit Add Catalog. I would give my catalog a name, so we'll just call it Deep JFrog Container Registry. This is a private catalog, so it requires a username and password. The scope is global. The Joomla chart that I'm showing you today is a Helm v2, but if you are using v3 charts, make sure to set this as a Helm v3. So I've got a v2 set up, and then the URL is just the IP address of my Artifactory instance. Again, because it's a private catalog, I do need to put in my username and password. And then when I hit create, you're going to see my JFrog container registry is active. So now what I can do is I can actually deploy that custom Joomla application that we set up. So coming over here to apps, I've already got my cluster started, cluster running. So second cluster right here. And coming over to apps, oh, sorry, second cluster. I actually have JFrog Container Registry launched in Rancher as well. So here in apps, what I'm going to do is I'm going to hit launch. And what it's done is that it's actually pulled in the Joomla custom chart. So right over here, we can see Joomla custom, Joomla. It's got that custom icon that I added. And here I can actually just basically launch this chart. And as it's launching, it'll take a few minutes. What I want to talk through is Rancher has a lot of tools and services that can help you manage security and enhancements for your application. So one thing that Rancher really does well is make these tools easy to connect to your application in the UI. Over here in tools, you can actually set up logging. You can set up monitoring for your application. Rancher also has ways to manage secrets. And one really cool thing about Rancher in terms of your Helm files is they add a questions.yaml file, which you can set up to help guide users through sort of key value pairs that might affect your chart in the UI. So on my desktop, here in the demo files, I actually have this created already. I have a questions.yaml file. This is an enhanced file for Rancher. I also have an app.readme.md. So if I open these two up, basically the app.readme.md is just a place where you can add some information, kind of a declaration to explain what your application does. It'll be shown in the Rancher UI. And then in questions.yaml, you can actually set up your own custom questions with variables to answer configuration options for the chart. And this is something that Rancher UI provides just to make it easier to manage different options in the UI itself. And it's something I really, really enjoy. So the Joomla chart is almost done installing. I guess while we're giving it another minute, we can start sort of wrapping up the presentation. So I mentioned ChartCenter and hosting, custom charts and pulling out charts from the ChartCenter. If you do create your own custom chart and you want to provide it publicly, you can add it to ChartCenter by clicking on Add Chart. Right now, since we launched just 5 weeks ago, the way to add your custom charts is by doing a pull request and providing us the source of the repository where your chart lives. So if we go to the live file, we have a repos.yaml file. You can see people have already added their repositories. What we need is the repository name, the source URL, and then really importantly, your maintainer name and email so we can contact you. And once you've sort of made your pull request, our team will review it. Any charts that you create and want to host publicly can be done here on ChartCenter. And of course, if you want to host your charts privately, you can use our JFrog container registry. Okay, so let's go see if my Joomla chart not ready yet. All right. So basically want to just wrap up, say thank you for watching the presentation and the demo. As you can see, Helm charts make it really easy to reproduce your security. All the configuration options are in the chart manifest files. If you're dealing with distributed teams, you basically can take your chart and send it over to your feature team, your QA team, your staging, your production, wherever they're located around the world. Everyone gets the same environment set up, the same security, and makes it super easy to keep your Kubernetes application safe. And like I said, what I really want you to walk away with here is kind of your own blueprint for understanding how to secure your Helm charts. So you'll have access to these slides afterward, but here I've listed sort of each of the specific steps I went over, including the mentions that I just showed you in Rancher. Okay, so now I hope my application's ready. Let's check it. Oh, all right. What we'll do is we'll break for questions, and hopefully by the time we're done answering questions, my Joomla chart will be finished deploying. Okay, so what questions do you have for me? Let's I think I'm supposed to look here in the chat. Go ahead, Connie. Yep.
Yep, sorry, I was on mute. We do have a few questions here, some centered around Helm. So the first one I saw was how to use the same Helm on multiple environments.
How to use the same Helm on multiple environments. I think what that question is referring to is if you have, like I said, QA, staging, production. When you create a Helm chart inside the templates folder, you can actually create separate folders for different environments. So what I've seen individuals do is they will create a folder called production. They'll create a folder called QA. Inside their QA folder, they'll have their YAML files that set up the configuration environment for that QA. They'll have separate YAML files under their production folder, and these can all live inside your templates. So you'll have different templates and different configuration options for your Helm deployments for your different environments. Okay.
Great, thank you. I hope that answers the question here. There was another question about how does Helm follow the API versions of my Kubernetes version?
Yes, so your Helm application actually declares inside where the sort of the Kubernetes, which Kubernetes version it's using. We don't have that listed on our UI yet, but one thing we're going to add is here where it says chart version, API version, application version. We're adding to the UI the metadata around which Kubernetes version it's also using, but it's something that you can set when you create your Helm charts.
Okay, great, thank you. There's one more question here that asks, how do we add sensitive data like my Docker image? I apologize, I'm not sure how to pronounce this correctly. Docker image is on GCR, I guess Google Cloud, and the URL is this tag. I don't want the project name in my value.yaml or anywhere where everyone can see it.
I'll answer that best I understand. Just like secrets, you can decouple information, sensitive information from your values.yaml file. You can basically declare the location in a different place. You can also mount this information. You can mount secrets when you're installing and deploying the application. Again, if you use something like HashiCorp Vault, what it'll help you do is it'll help you set up ways to bring in sensitive information only when you need it, and it doesn't have to directly live inside your Helm chart. Let's see.
Great, thanks.
Yep. Okay. Wonder if I did something wrong or it's just taking some more time. Let's see. Any other questions while I troubleshoot this thing?
Yeah, we do have one more here that asks, do you plan or how do you secure Helm deployment by blue-green deployment? Do testing of blue and switch to green by Helm chart?
Yeah, is that the whole question?
Yeah, that was the question.
Okay, so I'm not an expert on blue-green deployments, but you can do two ways. I think like I mentioned, just like you can have different folders for different configuration options, you can have different folders inside your Helm chart that point to maybe your configuration A versus configuration B. Again, when you install your Helm application, you can actually override the values in it. So if you want to have the configuration options from A installed for deployment 1, and then deployment 2, maybe you can override the values.yaml using the configuration options in your B folder. That's one way to do it. Another way to do it, of course, is just to have two different versions of your Helm chart and do A/B testing, blue-green testing with two different versions.
Great, thank you.
Yep.
If you have time for one more, Tycho asked, what would you consider to be the minimal requirements to establish basic security?
The minimal requirements, I think, are many of the things I mentioned. So if I was just to sort of talk about it without going back to my slides, I would make sure that the resource quotas are set up so that I'm not giving the application control of my entire virtual machine. So I would set my resource quotas. I would, when possible, look for charts that have provenance. So not every chart has a provenance file, but here we do. You can see on ChartCenter, for example, which ones do. So the chart info tab will tell you if it has provenance. By checking for provenance, you're creating a standard and a best practice for the Helm community to make sure that that chart is actually signed by the author. That's important, again, to make sure that that trust is established. I would use a trusted registry. I would grab the chart from the trusted registry. Inside the actual chart, I would make sure that you have at least some basic pod security policy enabled, some basic network policy enabled. And of course, if you do have any secrets in your application, like I mentioned, make sure that they're both encoded and encrypted. And the more complex your secrets, just use a tool like HashiCorp Vault to manage like the access credentials, the rotation, all of that. And just if you can get familiar with your hosted provider, whether it's Google Cloud or Amazon, they have a lot of these tools already built in. So sort of just make sure that you're using the tools that are provided to encrypt the secrets, to set up TLS. And I think that those would basically be the basics. And of course, as I mentioned, just do some basic checks around the Helm chart dependencies and make sure that you're not using any that have any red level vulnerabilities. So I think I think I've got a few minutes. I'm gonna try to redeploy my Joomla. I think I may have copied something incorrectly, but I wanna troubleshoot this and get this going. So we're gonna go back really quick. I'm gonna just do the Joomla installation from scratch. All right. So if we bring this back down, I guess while I'm doing this, Connie, if there's any other questions, I'll help answer them.
Sure. I don't see. Let me just double check here. I think we had gone through. Oh, there was a question about what is a feature test, but it looks like they had missed that portion.
What is a feature test? Okay. I think they're referring to when I was talking about the different teams that you might have or the different environments. Here at JFrog, one of the teams, so one of the processes on our team before we push a project to staging is we'll first push it onto a branch that we call feature testing. So that was just a reference to one of the teams or one of the build processes that we have here at JFrog. Yeah.
Got it. Thank you. A couple people have asked if you'll be sharing the GitHub repos or the links to them.
Yeah, I can share. I can definitely share those GitHub repos in my slides. Just remind me, Connie, and I'll make sure that those are included.
Great. Thank you.
Yep. Okay, so I'm going to repackage this Joomla chart and push this back up to my private registry. And hopefully by the end of this, we will be able to see that chart. So let's do Joomla 2. Okay. All right, so push that chart back up to my private registry, put it in a folder called Joomla 2 right there. Okay, coming back to Rancher, I'm going to refresh my catalog. It's already refreshing. And let's see if we can reach. I'm gonna wait for it. Any other questions from the panel?
Eric asked, is there a reason you used version 2 instead of the version 3 chart of Joomla?
Can you say that again? Sorry.
Is there a reason you used a version 2 instead of a version 3 chart of Joomla for the demo?
Just because it's the chart that was available on ChartCenter. There's no specific reason.
Gotcha.
Yep.
No other questions at this time.
Okay. So I'm going to give myself 2 more minutes to try to make this work, and if not, then that'll just be that for today.
No worries. Yeah, exactly. Live demos always. Never know what to expect, right?
Yep, exactly. Okay, so in Rancher's UI, just want to make sure that I'm refreshing it correctly. Oops. Okay, I think this is right. I didn't change the logo this time. All right, so that should work. We'll give it another few minutes. I guess while we're waiting, I can talk a little bit about sort of go back to the demo really quick, the slides. So right now, as we, the Helm community has moved into sort of Helm 3, there are a lot of sort of conversations happening around what kinds of standards and best practices we should introduce in the Helm community. So as we're looking at security and we're looking at how charts are tagged, I think one thing as you're building your Helm chart is just to understand that your YAML files, for the most part, can actually be named almost anything you want. But it's good to sort of learn from the community and see how they're naming YAML files, like their secrets.yaml and other policy files that live inside your templates. I know that Matt Farina talks a lot about the standardization. And on ChartCenter, one thing that we found is, given that a lot of Helm chart authors aren't tagging their files or are not maybe having a standard way to create the namespace, one thing that we are dealing with is any dependencies that are sort of in your subchart dependencies that have an extra namespace. They weren't resolving correctly on ChartCenter, so we built a custom plugin to resolve dependencies that have extra namespaces. But given that I have a few minutes to talk to you, I just wanted to sort of harp on the standards and make sure standards and paying attention to how charts and repos are named and how they're tagged, etc. Okay, so I'm going to sit here for a few more minutes until this happens, and I'm almost positive it's going to work.
Great. Hey, Deep, we do have a question about some recommendations. So,
okay.
Do you have any recommendations for best resources to learn Helm?
Oh, there's so many out there. I'm actually publishing a blog in a few weeks that's going to have the top 10 Helm resources. But what I found is really helpful is videos on YouTube. So you can type in sort of creating your first Helm chart. You can type in, pod security policy. You can type in Helm secrets. And YouTube actually has a really good, YouTube just has wonderful videos around each of these things. So you can look out for my blog that's coming out in 2 weeks, or you can just check out YouTube.
Great.
Okay. All right. Not quite sure why this isn't working. It was working all morning, but I think that that's just the reality of live demos. I think what's important to know, in the context of Rancher is being able to add your own custom catalogs. So again, you do that on the catalog space. Then when you're on your application, you can actually launch those custom catalog charts that you've added there. And with that, I will wrap up. Hopefully, maybe later today, my Joomla chart will actually have launched. And if you have any questions, I want to put my contact information up one more time. So here it is, deepd@jfrog.com. My Twitter handle is deep.x. And if you need to use a trusted source for your Helm charts, please do check out ChartCenter. Feel free to email me if you have more questions. All right.
Great. Thank you so much, Deep. This was an awesome presentation. I know, unfortunately, the demo didn't fully go through, but we will be sharing the slides and the link to the GitHub repo so you guys can access that info there. The Rancher user interface that Deep was showing is our flagship product, which is open source, so you can find that at rancher.com, along with all of these other products and projects here. Tomorrow, if you guys are available at 1 p.m., make sure to sign up for our August online meetup. And if you guys are feeling up to it, we do have a certification program available to become a certified Rancher operator. So you can check that out at academy.rancher.com. And thank you again for everybody who attended today. Thank you, Deep, for taking the time to do this presentation and demo.
Thank you.
Hope everybody has a great day.